Principles of Resource Economics, Section 2, Part H, Measurement of Resource Scarcity. Let's look at the consumption of raw materials in the US. We can see the primary metals, recycled metals, and industrial minerals. As you can see, the level of consumption is much more than recycled, and there is an increasing trend in the consumption of industrial minerals. So what if we run out of these natural resources? How would we know if we were running out of a resource? How do we measure the resource scarcity? Several available options for measuring resource scarcity are physical supply, economic supply, price, cost, and rent. Physical supply measures the amount of a resource which exists in physical quantities in the environment. May be too optimistic since some supply may never be economical to use. We can observe the source of energy by fuel source. We can also look at the undiscovered conventional and unconventional oil and gas resources in the United States and world. In the US, we have a good amount of coal available, which is enough for 9,000 years. We can also measure the amount of wildlife and marine resources. For example, in this graph, we have presented the Atlantic salmon wild fish stock population per year. We need to protect our natural resources and environmental services. One of the good examples is U.S. Endangered Species Preservation Act designation, which helped to protect the bald eagles in Georgia. As we can see in this graph, we have an increasing the total population of this bird. We can measure the level of solar energy produced. The U.S. Department of Energy provides average annual kilowatt hours per square meter per day. We can also have access to the level of wind energy produced. The second way to measure scarcity is using economic supply or reserves, which measures the portion of known physical supply which is economically available. It might be too pessimistic because of uncertain changes in price, technology, information, and other factors. And the nature of reserves is dynamic. Changes in time, price, technology, exploration, and cost of production may cause shifts in economic supply. For example, in this table, we are presenting some of the selected U.S. mineral reserves to extraction ratios at different years. For coal, we can look at the proven coal reserves as percent of world total. Crude oil reserves estimated at 26.5 billion barrels as of 2011, excluding the strategic petroleum reserves. Price is another method to measure scarcity. How does output price indicate the scarcity? Law of supply and demand. As scarcity increases, price increases as well. We should pay attention that price could be a misleading indicator of scarcity. Reasons are speculation based on false information, inflation, government intervention into market, manipulation of price through imperfect competition, political uncertainty, and measurement error. Price could also be impacted by international policies and pandemics. The fourth method is cost. How does cost, such as extraction cost and production cost, indicate scarcity? Well, as scarcity increases, it becomes more and more difficult to find, extract, and utilize new resources supplies. Thus, as scarcity increases, extraction and production costs are expected to increase. Most studies have shown that cost of obtaining even exhaustible, non-renewable resources has decreased over time, which suggests decreasing scarcity. What factors may cause cost to be misleading indicator of scarcity? First, technology. Decreasing costs may reflect technological advances rather than decreased scarcity. 2. Government intervention. For example, water subsidies in West. 3. Measurement error. Failure to account for external environmental costs of extraction or production. The last method is rent. Final measure of resource scarcity is rent, which accounts for changes in both price and cost. Land rent is equal to total revenue minus total variable cost. Concept of land rent was first introduced by David Ricardo. He was a businessman and politician, and a classical economist. Ricardo concerned about increased scarcity of high-quality farmland, developed the concept of land rent to measure scarcity. An increase in land rent on high-quality land implies that high-quality land is becoming scarcer. Let's calculate land rent. Land rent is equal to total revenue minus total variable cost. Total revenue is this area. Total variable cost is this area. Therefore, rent is this part. We also know profit is equal to total revenue minus total cost. So profit is total revenue minus total cost. Therefore, profit is this area. So once more, land rent is equal to total revenue minus total variable cost. Total cost is equal to total variable cost plus total fixed cost. We can switch these terms and plug back into the land rent and reach to this equation. So land rent is equal to total revenue minus total cost plus total fixed cost. Land rent is equal to profit plus total fixed cost. Land rent is equal to this equation plus this area. Summation of these two is the land rent. So total benefits of studying in production is land rent. Now let's compare three lands: grade A land, grade B land, and grade C land. The price are shown by those horizontal lines. As we can see, average variable cost and total cost of working in land A is relatively lower than land B and much lower than land C. Therefore, at a given level of price, land A can produce Q not A and land B can produce Q not B. The point that the intercept of price and marginal cost is Q naught A. This point intercepted by average variable cost creates the level of rent, which is this red area. In land B, because the average variable cost is equal to the price, then these farms make no profit and has no rent. And in land C, there is no incentive to produce anything given this level of price. But if price increases from P0 to P1, then we reach to the new level of output, both in land A and in land B, and also in land C. In land A, we have a higher level of rent. No, in land B, we have small level of rent. And in land C, the marginal cost is equal to price. So there is no point of producing anything in that land yet. If we could track land rent associated with prime farmland over time, this would probably be the best indicator of scarcity, rather than, say, food prices or production costs. Limitation are rents are very difficult to measure because of the data limitation. A common assumption is that land rent is capitalized into price of farmland, thus land price would reflect land rent and scarcity. However, need to consider price distortions. Rent is a good measure of scarcity since it measures in situ price, or the value of the resource in its natural state for a particular purpose. The value of prime farmland in its natural state for agriculture is measured by land rent. The value of a mineral resource in ground given by the royalty is equal to output price minus extraction cost. An increase in price or decrease in extraction cost will increase this royalty, indicating increased scarcity. Royalty is difficult to measure. One possible proxy measure is exploration cost. Assumption is that a mining company can spend rent on surplus of output price over extraction cost on exploration. In this slide, I have provided a numerical example.